Welcome to the Crunchly's Adventures channel. My name is James, and in today's video I'm going to be detailing the build process for the rocket behind me. This rocket stands over 11 feet tall, is 6 inches in diameter, and is made mostly of fiberglass components. Before I start walking you through the build, I want to extend a special thanks to National Science Foundation grant number 1953466 for providing funding for my rocket build, which led to my level 3 high power rocketry certification through the National Association of Rocketry. When I laid my carbon fiber plates, I decided to use a wax mold release on the mylar sheets. Some of this wax was still present, so here I am removing it with some isopropyl alcohol. I then traced a cardboard stencil I made with a silver Sharpie to mark out the fins. Got a little workspace set up with 2 buckets, one of these mounting sheets that I used to press the carbon plates, and then I'm going to clamp the plates so they don't move while I'm using the jigsaw. Let's get started. I decided to use a jigsaw to chase the lines I drew, which turned out to be pretty straightforward. The main downside was that the lines didn't cut perfectly straight. Because of this, I clamped all 3 fins together and wet sanded them to shape. In the end, I ended up with 3 identical fins. Kind of. Got the fin alignment jig put on and added tape where I don't want to get epoxy, and I also drew a straight line to indicate where my fins are going to go. Now I'm just going to do a little wet sanding so I can get the surface well and prepared to glue on the fins. So obviously this process of sanding the tube is going to remove the line. Don't freak out, I'm going to redraw this line later and simply wanted to prep this tube for bonding. So as you can see, the line I drew is gone. That's a good indication that I sanded enough. Could always sand more, but I feel like since I can't see that line, it's rough enough to accept epoxy. After sanding the other 2 spots for the fins, I rinsed the tube off and scrubbed it with soapy water to remove any residue present on the tube. I already put a tape line to indicate where I want to sand, and the first step is I'm going to clean off all the mold release or mold wax that I used. Very important because I don't want to sand that back into the fin because I want the best bond that I can possibly get. So I'll first clean it, then I'll wet sand it, and then I'll wash it off with soap and water, and then finally I'll wash it off again with rubbing alcohol, and then I'll be ready to bond the fin to the tube. Before I got to this step, I had to clean off the 4-inch tube with rubbing alcohol, and before I cleaned it off, I drew more alignment lines, and the rubbing alcohol kind of took them off, but they're still a little faint, so I'm happy with that. And then I also cleaned off the root edge of the fin with rubbing alcohol as well. The epoxy I used to tack the fins into place was extremely thin and took a few days to cure, as this was the same epoxy I used to laminate my fin and centering ring sheets. This is not even close to the correct epoxy to use to tack fins into place. Ideally you want to use something strong but relatively quick setting, like 30-minute epoxy. The fin jig saved me as it was able to keep the fins in place for the multiple day cure. The centering rings were simple to cut out using the jigsaw, but the edges left were pretty rough. I didn't attempt to cut out the center with the jigsaw and went straight for the scroll saw. I thought I had an ingenious hack to cut out the centers, but it just did not work as I had planned. So I got the jig set up so that I can turn the centering ring, and what I'm hoping is that it'll cut a perfect circle, since that is exactly the diameter of the tube. I guess we'll find out. Obviously I don't want to cut through the centering ring, so I had to drill a hole in the center for the blades to pass through. I hoped that rotating the blade around the centering ring would cut a perfect circle. The truth is that there was just enough play in the system that some lateral force was present on the blade. This forced the blade to slightly walk and ended up cutting further inside the line than I would have hoped. Luckily for me, it cut inside the line, so I just flipped the ring over and cut the remaining bit out. I didn't try cutting the line freehand, but I bet it would have saved more time than spending time designing and messing with this jig. Off camera, I wet sanded the centering rings and engine tube with 220 grit sandpaper. Then I dry fitted the centering rings and marked where I wanted the centering rings to go. Before gluing the centering rings to the tube, I wiped both them and the tube off with rubbing alcohol to remove any residue. I decided to put some tape to act as a stop so the centering rings would be placed exactly where I wanted and would be perfectly perpendicular to the tube. This worked okay, and I would definitely use this technique again, but it wasn't perfect, especially with the homemade centering rings. A big problem with this is that I used thin epoxy. I just felt like I was coating the tube with water and I didn't get the satisfactory stick that 30-minute epoxy gives you. It felt like if I looked at the rocket wrong, then the centering rings would shift. With the fins and centering rings tacked into place, I was ready to start the internal fillets. I used a faster curing epoxy, which I hoped would be more viscous, but it wasn't. Don't be like me and choose something other than laminating epoxy when you're doing your fillets on your rocket. I added a chopped fiberglass to strengthen the epoxy, and it honestly looked like I put rice in it, which I found funny. The rice-looking fiberglass helped thicken the epoxy a little, which helped when I applied the epoxy onto the rocket. This process worked far better for the fins than the centering rings because there was a valley for the epoxy to fit in. On the centering rings, the epoxy was thick when I applied it, but it seeped out of the fiberglass and did not sit as I had hoped. I also spent a little time cleaning up the fillets with a popsicle stick. They are never going to be seen once the rocket is built, but it's the thought that counts. Since the tube I ordered didn't have any slots in it, I had to manually slot the tube. I first drew straight lines on the tube 120 degrees off from each other. I offset these lines by 1/8 of an inch on both sides and cut these lines out with the jigsaw. To make the end of the slot as clean as possible, I drilled a hole for the jigsaw to cut into. Other than a little bit of flashing on the edges, this seemed to work great. I also had to cut the upper body tube section down to size. To mark the tube, I taped 2 pieces of paper together, wrapped them around the tube, and taped this to the tube with painter's tape. I then marked the end with tape, being careful to note which side of the tape I would need to cut on. I used a hacksaw to saw through the tube, which was a slow process but yielded a good result. The inside of the body tube has been sanded. I sanded along where the centering rings will be, and then Anita and I put some Mylar. I just put a bowl to stop any epoxy drips, and there we aluminum taped some Mylar so the epoxy won't get where the coupler fits. And we're getting ready to insert the fin can into the body tube. Just marked this part right here because we need a screwdriver to prop that to the side so we can fit it. For some reason it doesn't like that last centering ring. We also taped both ends of the fin can so no epoxy at all can get inside and screw anything up. I was daunted by the process of gluing the fin can into the body tube, but I just had to go forward with it. Luckily, Anita was there to help guide me through the process. We painted each centering ring with the same epoxy I've been complaining about throughout this build. We slid the fin can in centering ring section by section so that I could have time to use a syringe to inject a good amount of epoxy onto each centering ring. It's hard to tell if this worked, but I hoped that the epoxy would flow in between the centering ring and the inside of the body tube and create a reinforcing fillet. One of the best things I learned that night was to use a hose clamp to clamp the end of the slotted body tube to the aft centering ring. The tube never fit flush against this ring, and the hose clamp pushed it as close to the tube as possible. Just taking off this hose clamp right now. What we use to make sure everything is seated right. Okay. Really interested to see if my bowl technique works. Looks like we did get some epoxy.
It's not bad.
It's not bad. The bowl, it looks like it just, oh, it's inside the Mylar.
Oopsies.
Thank goodness.
Does not go up like it used to, or before it comes down like
just mixing the 4-to-1 epoxy right now. Just getting ready to put some milled fiberglass in, picking it up for these fillets. After I finished shaping the fins, I sanded the fins and the section of body tube between them to prepare for a tip-to-tip carbon Kevlar layup. Shortly before this layup, I cleaned the surface with the old trusty isopropyl alcohol. Just to let you know, Kevlar sucks to cut. They require special serrated scissors, and the serration cuts are on the cloth anytime you move the scissors. This means that you never get a clean cut. The layup starts by painting a coat of epoxy on the fin and body tube surface, which is followed by carefully laying the cloth from the tip of one fin to the tip of the other, being extremely careful not to screw up the weave of the carbon fiber. Slits were then cut at the end of the fin so that the cloth could drape down and would be in contact with the entire surface of the fin. It's pretty simple after that. You just need to get the cloth wet. Maybe you want to use some higher quality brushes that don't shed bristles. Just saying. They can only be used once, so don't go too overboard with expensive brushes. I decided to go with 2 tip-to-tip layers to help thicken the fins, which turned out thinner than I had hoped. Once again, same process as before, however, since it's the second time you're doing it in a 30-minute period, this should come easier. It's good news, though, because any previous mistakes you made will be covered up, but any mistakes made now will be shown. I finished off the process by placing a layer of nylon cloth on top and painting it just like I did the carbon sheets. It's tricky to remove all the bubbles, but this helps smooth out the surface. I didn't iron these sheets, and any wrinkles in them showed up later. Oops. Before the epoxy totally cured and was still slightly malleable, I used a razor blade to cut off the excess cloth. This is a great technique as it really cuts down on the sanding you must do later. There are like wrinkles, but oh well. Obviously there is a gap left by the added layer of carbon on the surface of the rocket. Like any sketchy restoration, I filled that gap with my favorite mistake concealer, Bondo. I would fill in the gap, sand off the excess, and then add more Bondo to fill in the gaps I missed, and sand even more. The nylon also left its weave pattern in the fin, so I sprayed a few coats of clear coat, sanding the fin surface in between each coat to remove the high spots. To make a tail cone for this rocket, I 3D printed a mold with PLA. I ended up wasting a bunch of time by coating the inside of the mold with Bondo because later I sanded off most of it, which was a tedious and frustrating process. Next time I may just skip this step. The mold was coated with a wax mold release, and to start the layup I coated the inner surface of the mold with epoxy. I then laid small strips inside the mold, wetting them out with the paintbrush. They didn't want to stick to the inside of the mold, I don't know, maybe because the mold was coated with wax. At this time, I was having a total mental breakdown, and I just stopped laying fiber when I thought I had enough layers. Did you see that green partial cone looking thing? Yeah, I shoved that inside the mold, which forced the fiber to fill the mold as I wanted. This would have been a total disaster if I skipped this step. Seriously. I'm starting to learn that when you 3D print a mold for composites, it's single use. We had to break the mold to simply free the tail cone. Honestly, this process was pretty fun, but there were some sharp fiber edges that we had to be careful not to cut ourselves on. So I was able to free the tail cone from the mold. Still got to trim off the top portion, but other than that, it fits. Super hyped, honestly. And interestingly enough, that green filament was really brittle, but the pink almost stayed intact when I pulled it from the mold. I don't know if that's because the wax on that side was just better, but it was much less brittle. The green stuff on the tail cone right now, that's excess Bondo that actually got pulled off from the mold. So now I got to start working on sanding that off. I'll trim off the top, and then I will work on bondoing this area so it's nice and flush. I got it marked where I want to cut. So I'm gonna go and take the hacksaw and cut around this tape mark. Finish cutting it off. It's a little raggedy, so I'm gonna sand it off real quick. Finished cutting it off. I used a 32 teeth per inch hacksaw blade instead of the 24 that I used on the bottom section, and that seemed to do a lot better with the Kevlar, and I also sanded it a little bit afterwards. We got some gaps, I got some Bondo I need to do, and it's not perfectly seated, so I might have to do a little sanding inside the tube, but overall I'm really happy with how my first tail cone turned out. So I made this jig, I 3D printed it. So these holes, I haven't decided where I want my switches to go yet, so I'll do those later. But there's a hole every 120 degrees, so hopefully they'll be perfectly aligned. Oh. Before I drilled the holes for the screw switches, I drilled 1/8 inch pilot holes. I also put hardware in the corresponding shear pin holes I drilled earlier, so I could drill through the vent band and the coupler at the same time and they would stay perfectly aligned. Unfortunately, the holes flashed a little. I drilled the original holes in the bolt plates with a hand drill. This turned out to be a total nightmare. Not only did it take half a drill battery to drill a single hole, but the bit walked even when I drilled a pilot hole, not to mention that the whole thing would get ripped out of my hand when the bit broke through. You got my little jig.
Got a little jig
to it.
Then we got some pilot holes that we made with these jigs over here. Ooh, that sounded violent.
Dude. The idea with the bolt plates is that one just fits inside the coupler and the other fits on top of the coupler. This helps with alignment and makes the electronics bay easier to handle when outside the rocket. The U-bolt holes were true enough for the most part, but the holes for the all-thread were not. I filled them in with 30-minute epoxy and used a 3D printed prototype of the reinforcing bracket to act as a guide when I drilled them for a second time. This time, the second try was the charm. More than likely, I glued on the switch bands crooked because there are quite large gaps left between the connecting sections. What do you do with gaps when you wish they would disappear? You fill them in with Bondo. I did my best to go around the tube filling the gap as I went. Do you see those marks on the tube? Yeah, my ingenious jig that would perfectly align the hardware holes didn't work. Hence, only one hole on the coupler lined up with a single hole on the body tube. I put graphics on the rocket later, so this made remembering these hole combos easy. This time I only had to spend about a half an hour sanding Bondo. Progress. Looks like did the trick. Just get some of the rough edges real quick here. The result was quite pleasing, and I sanded the Bondo slightly more to improve the appearance that the tubes fit perfectly together. When I started designing this rocket, I basically took a Lock 3-inch laser lock and doubled it in size. This led to the fin span being quite questionable, especially when the rocket gets close to Mach. Because of this, and the fact that I maybe would like to put an O motor in this someday, I cut an inch off each fin with a hacksaw. Not a fast process, but it worked. I really liked the fin shape before I cut them down, but as my mentor Denzel told me, after a launch, an intact rocket looks a whole lot better than a rocket that shreds in midair. I like starting all my paint jobs off with a good coat of white primer. I find that this helps the colored paint show up much brighter. After painting it white, a ton of pinholes appear. You know what I use to fill in pinholes? Yep, glazing putty, not Bondo. It works a lot better for small holes and is a heck of a lot easier to sand off. After recoating the rocket with white primer, I wet sanded the surface and cleaned the tube off with a damp towel. I named the rocket Mile High 2 and painted the rocket orange and blue. I used automotive paint which sprays on very thin. So I finished putting the stencils on. I'm going to paint around here and around there with primer again, just so the orange doesn't bleed through too bad. And then I'll get to the blue. After masking off the orange section, I sprayed on white primer to give a good base coat for the blue. I painted about 5 coats of each color, waiting 10 minutes between each coat. Okay, I finished painting. Now I'm going to start unpeeling the masking tape. I was very excited to place my custom-made vinyl decal to officially name the rocket. This was my first time using a Cricut to cut vinyl, and I think it came out great. Luckily, my mom helped me align the stencil. It was pretty long, but honestly pretty easy to align with my mom there. I made sure to press down the vinyl before removing the transfer tape so that the vinyl would adhere properly. I also carefully removed the transfer tape so not to remove the decal below. To finish off the rocket, I filed the slimline motor retainer to bare metal where the tail cone will attach to it. I then glued on the slimline motor retainer. Next, I glued on the tail cone. Because of the heat this section will be subjected to, I decided to use JB Weld.